breaking the action for a moment, I want to say that the Askia company is a company that I think has three values, which is the value of creativity, intelligence, and fun. And one thing about small organizations is that they take on the personality of the leaders of the organization. I point you to two people who are who creative, intelligent, and fun, Jerome and Patrick. So thank you. Okay, I'm more sort of a user of Askia rather than a person who programs in Askia. So what I want to do is in some ways talk to you about the kinds of things that we've done using choice models to understand what consumers are all about, but also look forward to the future of the kinds of things that I think are going to be happening in the future of marketing research. And I challenge you as the people who are creative in your own right to try to help and think of new ways to help me do my job better along the way, okay? So the usual sort of commercial about who we are. Our organization is only about 2 years old, but I've been working in marketing research now for, I think this is my 31st year in marketing research. I'm a lot older than I look. That's a good thing. We've won awards, as he's mentioned. We work very closely with a lot of academics around the world, and what we do is we take a lot of the stuff that they've done, the advanced models that they've done, and we make them into commercial kinds of applications and code. We work both with existing databases, so we work a lot with Nielsen and IRI scanner data, and we also work with surveys, experiments, taste tests, sensory testing of one kind or another. What I'm going to be talking about specifically today are things that are more in the survey area, but we've built our own software to do advanced statistical modeling using what are called Bayesian hierarchical models. And these models are optimized for handling very, very large databases. I know the gentleman mentioned a 70 megabyte database that he analyzed. We typically analyze databases of a half a terabyte or more in size. We use cloud computing to do that. We're also getting into what's called using the graphics processors on computers. So right now we have a central processing unit on your PCs, and what happens is that graphics processors have their own CPUs, but so the amount of memory that each of those CPUs can address is very, very small. But typically you might have 500 or 1,000 processors on a graphics processor. So what's happening right now in the high-speed computing world is that a lot of applications software is being written to take advantage not only of the central processor on your computer, but also take advantage of the graphics processors. And so what that allows you to do is do parallel computing. Essentially, you're going to have a supercomputer on your desk. The next year is when the first generations of these machines will come out that allow you to address both of those right now without regard to knowing which one you're addressing. Right now, you have to specifically address either the graphics card or the central processor of your PC. And again, this is happening at PC. We're typically running, when we run those big databases, we're using 80 or 90 megabytes of memory. And we're doing it through cloud computing to do these kinds of analyses. And so those analyses are typically looking at Nielsen scanner data. So we'll have, we just finished, for example, an analysis for Hershey's, which is a chocolate bar company in the United States, where we analyzed 10,000 SKUs, sales in about 2,000 retail outlets, all weekly data over a course of about 3 years. And that was just about a half a terabyte of data that we did an analysis on. And it took about 3 hours for the models to converge, which is enormously fast, believe me. It doesn't sound like it's fast. A year ago, before we started developing this software, a job that long would have taken us a week or two. So we've gotten the time to be really amazing. So what is choice modeling all about? And really what understanding what sales is all about, and what understanding what surveys are all about, we want to understand how consumers make choices. We want to understand how people make choices. And allowing us to understand these kinds of choices allows us to answer lots of different kinds of questions. I'm not going to read what's on the screen. You can read it for yourself. But the idea is we really, if you think about reporting weekly sales of a particular product at let's say a supermarket, those weekly sales are really the aggregation of individual choices that individual consumers are making. So what we want to do is to be able to have technology in place, the ideas in place, and the models in place to be able to understand those individual consumer choices that are going on. As Jerome mentioned, I've been working in the area of choice-based conjoint now for, I think it's 17 years, I believe. And those of you who've done a Choice Based Conjoint have heard about Choice Based Conjoint. You may have used Sawtooth. Sawtooth, I started working in 1983 on Choice Based Conjoint, and Sawtooth came along in 1993, so it was 10 years after the work I was doing. They commercialized it, and it turns out those of you who know about MaxDiff, I presented MaxDiff at a conference for Sawtooth in 2003, received the award for best presentation, and then they commercialized it, and I received nothing. So there we are. Oh well. Anyway, I want to kind of give you a little background. What we really want to understand is how people make decisions, and this is a typical decision funnel that you see looking at a marketing textbook where people kind of have a need that a need is aroused along the way. They go out and they search for alternatives. They learn about those alternatives, and then what traditional conjoint tries to do is to understand how people evaluate those alternatives and then predict their preferences out of that. What traditional conjoint does, is it then will simulate people's choices based on their preferences. What choice-based conjoint does, oh, sorry, I realize this doesn't move it, I have to wait for him, is that it looks at the choices that people make. And we sort of bypass, if you will, the preference formation part of it all. What we do is we go directly from people's evaluations to the choices that they make. And the choices people make are for particular alternatives, in this case alternative A, B, and C, but other kinds of alternatives that people might make would be to delay making a choice. So I'm not going to buy today, I'll buy tomorrow, the prices are too high, or I'm just not ready to buy. Or they may say, I'm not going to buy any of these whatsoever, I'm just not going to buy at all. And that's a choice as well. And when we try to model these kinds of things here, obviously we can model the alternatives people choose by the features, the brands, the prices of the things that are available, but then the kinds of things that, in terms of delay, and none of these are different kinds of things that we need to model in their own right and understand what are the things that get people to move from, let's say, choosing nothing to choosing something. And that's how we're predicting demand. If people don't buy anything, demand is low. When they buy something, demand is high, if you will. Okay? So, basic assumptions that any kind of choice model makes are these, which is that products are really bundles of features that are put together. People are going to make a global evaluation in their heads. We're not asking them to evaluate each of the features of the product individually, but rather they're coming up with some general evaluation of the product. And if I can make a little joke in English, the joke is, which part of Gestalt don't you understand? The psychologist in the room. Some of you got it. Okay, anyway, each feature will add or detract from the overall value of a product, and what economists talk about in microeconomics or in consumer behavior is that people will maximize the utility, that people will choose the thing that offers them the most value, the most utility. So everybody's going to buy the thing. Now there's a lot of things that happen that make that not exactly right, but for the most part it's an assumption that's the core of any kind of microeconomic theory, is people are going to maximize the utility of what they choose. We also, in the conjoint sense, we're going to give people multiple tasks, and by getting people to choose multiple things, they're going to give us a consistent view of what their preferences are all about. And then what we're going to do is we're going to take those choices and we're going to decompose them back into the parts that are attributable to the features, the prices, the brands, and so on along the way. And the final assumption we make is what we make a lot of in marketing research, is that when we give people sort of these hypothetical situations, it's going to reveal something about their behavior that has some basis in the reality of what they actually do. Okay? What I'm going to talk about today is really the bottom two to start. So right now we're looking back. As I said, there's choices backwards and forwards. Right now we're looking back. So I want to sort of set the stage for what we've been doing before I tell you what I think is going to happen in the future. So the first one is discrete choice models, choice-based conjoint. And those of you who aren't familiar with the history, this really comes out of, it really comes a melding of two things. Marketers in the 1970s, notably a gentleman named Paul Green, who was at the Wharton School at the University of Pennsylvania, sort of stumbled upon this idea that we could talk about products and features that were considered jointly, conjoint, and that's where the name came from. Things were considered jointly. And that we could then use the fact that people are considering all the features jointly, making that overall global evaluation, and we're going to predict what their preferences are. And then what we're going to do is simulate the choices, I said. The weaknesses of this is that there's low external validity. In other words, people didn't believe that you can actually ask them about these preferences and find out what they really felt. And that was because, for the most part, there was no competitive situation going on. I can ask you, how much do you like this computer? But most people do some search. They look at several computers. And most people are very good at doing comparisons and are lousy at saying giving us a good evaluation of what this one thing is all about. As soon as I show you this one thing, I show you something else, you might change your preference in some way. So you have to incorporate competition into these models. At the same time that this was going on in the civil engineering and econometrics world, there was a fellow named Daniel McFadden who was at MIT, and Daniel McFadden won the Nobel Prize for Economics, I think in 2004, 2005, for the work that he did in choice modeling. And the idea was the original funding that he had was for from the U.S. government, and he was working, trying to understand how to get people out of their cars and onto mass transit. So a lot of the money was funded by the U.S. government looking to fund what is it that makes people drive to work versus take the bus or the train to work. And with that kind of data is what was called RP, or revealed preference. You tell me how you go to work, and tell me all the things about how you go to work in terms of the price, the time, the convenience, the comfort, all those things. Then tell me about all the other things about the ways that you could go to work but didn't choose. So price, time, convenience of driving, price, time, convenience of riding a bicycle to work, of walking to work. And then what I'm going to do is build a statistical model that will explain, based on all that, why you chose the option you chose and why you didn't choose the things that you didn't choose. Okay? The problem with this is there's really very little variation at feature levels. And what I mean by that is if I say to you, what was the price of taking the bus? Well, there isn't any variation. The price of the bus is the price of the bus, is what it is. And so when you looked across, let's say if you're trying to do an analysis within a particular city, well, if the price to take the bus is, 1 or 2 euros, no matter where you are in the city, you've got no variability to explain the differences in people's choices. And what happened was a fellow named Jordan Louviere came along, and he sort of melded these two streams together with one another. He took the technology from the things considered jointly from the psychometricians and Paul Green at Wharton and married it together with the choice models of Daniel McFadden at MIT. And that's how Choice Based Conjoint was born, okay? This happened at around the mid-'80s, thereabouts, how these were born. So let me give you an example of different kinds of choice tests. You've probably seen these. I'm going to go through these pretty quick. And this is an example of something I had done for a book publisher. So there's different publishers across the top. Those are the competitors. Along the sides there are features. Each feature has a level. So Alpha Company is going to give us a student reader with stories. They're going to give us a historical content literature, whereas Beta Publishing is going to give us type of literature that's contemporary literature. And then what we did was we spoke to in this case, it was people who were adopting books for use in their schools. They chose one, or they said, I don't want any of these. I'm going to choose something else from some other publisher. And this way, and then what we did was all the things in the middle there in terms of the levels of each of those features and for each of the competitors, you then show them another menu, if you will, another set of services that are available from the same publishers or different publishers, and you kind of keep rotating these, just recording what people chose as well as what they didn't choose. And from this, we can build a model that tries to predict what are the things that are driving choice. Here's another one, and this is work that I had done actually just before the Telecommunications Act of 1997, I think it was, in the United States, which essentially deregulated and allowed AT&T to be broken up into the 7 regions that were then the big telephone companies in the United States. And in this case, what we're doing is what we call an allocation task. So we were talking to business managers who were buying multiple phone lines from potential competitors. Our company, let's say, was the first column, which was your current local telephone company, and they were worried about once the phone AT&T was broken up, they were worried about if they were providing services, let's say in California, they were worried about a company that had been part of the breakup that was in New York coming in and providing services competitive to theirs. So that was the best out-of-region phone company. That was the third choice here. So after I finished this study for them, they used the simulator that came out of this for 2 years afterwards to do planning and so on. Another example that we had done, and this was early on in the world of wireless phone service. This is back in the day when a wireless phone kind of looked like a walkie-talkie. It was about so big and like that big, and people used to have a backpack for these things. And what we were looking at in this case was to try and simplify the pricing plan. So the one on the left for mobile cell, this is sort of a pay-as-you-go plan. The one in the middle was unlimited usage plan, and then the one on the right had right here in particular, this is what's called a tiered service. So if you use it this much, it's going to be so much per minute, and then you use it more, price will go down, and price will go down, and price will go down. This is what's called a joint choice and volume model, in the sense that first you choose one of the providers, and then you write in the number of minutes you're going to use it. And so you can have the choice part, and then given the choice you made, how much would you use it is the volume part. So this is a joint choice and volume model. These can be done as well. So we're talking about right now really old technology as far as I'm concerned, but maybe new to some of you, but these are the kind of things one can do. Some of you, how many people, can I show you a show of hands, how many people have heard of Best Worst? Oh dear. Okay, so we got a dozen or so. Okay, so what is this all about? Well, really what this is all about came about, I was thinking, this is in about 10 years ago or so, I was thinking about this kind of data collection, where we want to understand what's important to people and what makes decisions. And of course, being good market researchers, we know how to ask questions. And we ask a question like this, in this case, these are, we're asking IT managers what's important to them when they buy a file server. And so it could be, the service and support's important, the reliability is important, the redundant design is important, the performance of the server is important. They're all important. And as no doubt many of you will say to yourself, well, if I give it on a 1 to 5 scale or a 1 to 10 or a 1 to 100 or whatever scale you like, everybody's going to be rating everything high because these are all really important things for file servers. And I always found that when I was doing these kinds of studies, the results, didn't get much differentiation among the items. And I could always throw that into some kind of multivariate analysis, but I always got junky results. I was never happy with the results I got. And I said to myself, there's got to be a better way to ask people's preferences than just say to them, how important is this to you? And this gets back to the thing I just talked about with people making trade-offs. So let's take a look for a second at what we've got. We could ask people to do a rating. It's easy for them to do these rating scales, but it really doesn't force people to make differences between things that are important to them. Another thing we could do is we could take all the items and ask them to rank the items, so from most important to least important. The problem is that you get low reliability, meaning you're unlikely to get the same order if you do this more than once from the same person. So results could be very unstable. On the other hand, some people might argue to do something called derived importance. And the problem with derived importance specifically is that attribute features that have little variation will have little importance. So example, I'll give you a silly example. If I said to you, when you buy your next car, how important is it to you to have a steering wheel on the car? On a 1 to 10 scale. Now my guess, if I ask everybody in this room, we're going to get a lot of 10s on that. But the problem is if I now say, what's the relationship between having a steering wheel and buying a particular car, you're going to find there's no relationship because essentially it's a constant, meaning everybody gave it the same answer, trying to predict a variable differences in purchase intention. So what we need is some kind of methodology that's going to give us the relative positions of these things along the list, make it fairly easy for people to do, but it's also going to force the differences among them. And what we do is we put the task in chunks, and I apologize for using the word chunks because I've done part of this seminar at SMR before. A chunk is really, we're going to make the task smaller for people. We're going to make little tasks as opposed to one big task. We're going to put it in little pieces, and we're going to give people little bites to eat at a time. Okay? So what do the little bites look like? Well, here we have that example I just showed you with the file server. And what I'm going to do is show you 4 attributes at a time. If you look at the 4 attributes on the left, warranty policy, security, lowest purchase price, and brand name. And all you're going to do is tell me which of these is most important to you and which of these 4 is least important to you. Then I show you another set of 4. And in this case, you're saying most important to you is the upgradability, the least important to you is the brand name. And I do this several times, like you do in a conjoint. You get these little chunks. You might do a dozen of these little chunk tasks, each time asking you for a most and a least. Now, the chunk task actually requires people to make trade-offs. I can never say that everything is totally important to you. It's a choice-based task, which I know a little bit about doing. Third, if you do your experimental design right, it's going to control for the order bias as well as the context bias. Order bias means that, let's say, warranty policy is going to appear in the first position, the second position, the third, and the fourth position an equal number of times across all the little bites, the chunks you take. And context bias means that warranty policy is going to be seen with security features an equal number of times as the warranty policy with the low purchase price. So there's no sort of thing where something didn't appear together and so you don't really get those rated against one another. It turns out the combination that we call the most least is the pair that has the maximum perceptual difference. And that's why it's called max diff or maximum difference scaling. Now, for those of you who haven't seen it, I'd like to give you an intuitive explanation of why this works and how it works. So if I were to show you, you're on time, very good. If there are 4 items in this little set, it turns out there are 6 pairs that you can compare to one another. 4 times 3 divided by 2 gives you 6. 6 possible pairs. So if I say to you the most and the least was upgradability and the least was brand name, what do you really know about those 6 by just doing those 2 tasks? Well, what you know is that the upgradability, since you told me it was most important, has to be more important than tech support. It has to be more important than redundant design. It has to be more important than brand name. And since you told me brand name was the least important to you, we know that brand name is less important than tech support and less important than the other 2. But since I've already know that upgradability is better than brand name, I know 5 out of the 6 pairs. The only pair I don't know anything about is the redundant design and tech support pair. But given I've got 5 out of 6, and I do this across a lot of tasks, I do this a lot of people, I can get a good feel for what the heck is going on and what people really care about. So what happens with these data? Well, when you're done with these data, you don't have to deal with those crazy mean scores on a 1 to 5 or 1 to 10 or a 1 to 100. You actually get scores that look like that. So there's big differences between these scores. And you can see, from top to bottom, you've got almost 200x difference between the thing on the bottom and the thing on the top. So you get much, much bigger differences using the max diff kind of scaling than other kinds of scaling techniques. Now, the second thing that you get out of this is that you can actually conduct a segmentation analysis very easily out of all this. And here's what segmentation analysis might look like. And what I'm doing is the things that are in the green color, the teal color, are the things that are important to that segment. So you can see that we get good differentiation across the segments. Things that are important to, like, for example, if you look across this brand name row here, you see there's 1 group out of the 5 for whom brand name is very important. You can see there's what I want to show you, lowest purchase price is this row right here. You see one of the 6 rows has really important low purchase price to them. And so the people that are easy to buy and maintain, you think what's important to them is reliability, performance, ease of maintenance, repair, warranty, and a low purchase price. The people who never breaks, reliability is extremely important to them at 600. And performance is important, but the redundant design is at 300. That's the only group that really cares about redundant design. So you can get these kinds of analyses out of it. And this data collection technique is part of the software suite at Sawtooth, but it's certainly easy enough to program yourself. I program myself all the time. It's a balanced and complete block design, and then we'll do a little fancy math underneath the whole thing. So talk to Jerome and Patrick about getting it in. So I highly recommend it. So what's the future going to be like, given that we've had these 2 things in the past? And my 4 predictions are people are going to be doing menu tasks where they have to build their own product. A second thing is we understand the concept of what I call trading up. This isn't trading off, this is trading up. And I'll tell you what that's all about. The third one is understanding affordability in addition to understanding price sensitivity. We know consumers are price sensitive, but many of you have probably heard the phrase choice under constraints. And people's budget, what you have in your wallet, is your constraints. So we want to understand what's the maximum you can afford to pay for a product as another way to understand what consumers are all about. And then the 4th thing I think is really cool, and actually I have the most slides on, but there are a lot of pictures, so we'll go through them quickly, is getting consumers more involved in the design of products, industrial design. So let's take a look at these in a minute, what these look like as far as tasks. The first one I call menu-based conjoint analysis, and this is actually a quote from a paper that was done in the Journal of Marketing Research in 1997. And what it says is, from a marketing research point of view, the focus is no longer on conjoint analysis studies leading to the identification of an optimal product or product line, but rather on the following: identification of the set of features and levels that typically constitute the conjoint analysis task, the way that consumers want to customize their products, and the premium, if any, that consumers are willing to pay for a customized design versus an off-the-shelf product. Then we use the consumer input not only for designing customized products, but also as a response to a conjoint analysis type task that provides the operational guidelines for the designer products to inventory for the segment that has not willing to pay for the premium required for a customized product. Now, I read this article with great interest, and I said, what is this conjoint analysis type task that they speak of? Well, of course, they never told you what it was. So I went to a professor friend of mine, and I said, we really got to figure out how to do this. This is really cool. So what we came up with is something that we call menu-based conjoint analysis. MBC, or MBCA, menu-based conjoint analysis. And the idea is that each person is going to evaluate a menu where the prices of the menu items are going to vary across the menus. People are going to have it their way, and we're going to assess the feature demand directly for each of the items on the menu rather than getting a whole product together. Now, I say to all of you, think about what you do when you go out to dinner, let's say. Some people might buy an entree and a main dish and a dessert and have a beverage. The next person may skip the entree, they may just have a main dish and a beverage and a dessert. The next person, my wife orders 2 entrees, no main dish, and a beverage. So everybody is doing something different. You're all mass customizing, if you will, your meal, and the restaurant is gracious enough to do that for you within certain constraints of what they can cook, and that's what they're going to give you to eat that night. At the same token, take that same idea and think about when you go to, let's say, the website of a Dell or an HP or some computer manufacturer. They want you to, essentially, they'll either give you something that's pre-built, that's the product that's inventoried for those who don't want to customize, or you can go customize and make your own machine. You can get whatever processor. They'll give you a list of processors, you pick one. They'll give you a list of graphics cards, you pick one. They give a list of memory available, you pick one. So it's the same kind of idea where everybody is mass customizing. That's my wake-up alarm, actually, believe it or not. Good thing, good thing. So this is a little case study of what we did with this menu-based conjoint analysis. And by the way, this was we were nominated for 2 awards for this paper. We didn't win, unfortunately. But this paper was published, I think, in 2001 or 2002, and Sawtooth just introduced menu-based conjoint analysis, not the way I do it, the way they do it, which is not as good. But at any rate, so what was it in this particular case? It was a telecommunications company that wanted to introduce what they called an enhanced wireless phone, EWP. And then with this enhanced wireless phone, you can then buy things to add on to the enhanced wireless phone. I'll show you some kind of things that they could buy. And so the question was, who was going to adopt the phone? How much would they be willing to pay? How price sensitive were the various features and products and services that could be added to all that? A challenge in this is, traditional conjoint would show you a phone, and here's all the things bundled with it. And here's maybe another phone bundled with it. Choose which one you would buy. It's not appropriate for this kind of situation because everybody is essentially choosing what they want. And I happen to believe if you want to get good answers from people and make those answers sort of mimic what the real world might be like, you've got to give them a task that looks like what they would do in the real world. And in the real world, people will be mass customizing, choosing their own features and products that they wanted. Unfortunately, you can't read this very well, but these are separated into sort of 1, 2, 3, 4 different types of things they could do. They could watch TV, they have portable media, they can have a camera, and they can have additional features. Along the middle are all the optional features, about 20 of them, roughly speaking. And on the right, we price them for them, and then every time they tick the box to say, I want this one, on the bottom, it totaled up what the total was. When they were done, they said, I'm done with this menu. We then showed them another menu, which could have different features available or the same features, and it could have the prices changing. And then when we did the total, go to the next one, we showed it to them again. So you kind of keep showing them different menus, and you're trying to get what are the things they really got to have no matter what the price is, what are the things that are price sensitive to. Am I doing okay on time, you think?
Listening.
You're listening, okay. Okay, great. So let's take a look here. We had each of the enhanced phone and each of the additional services were presented at 3 price points. So we had about 20 things. And if you think about it, anybody could pick 1 thing, 2 things, 3 things, 4 things, all the way up through 20 things. So it's a combinatorial problem where it's 20 things taken 20 at a time, taking 20 at a time, meaning you chose all of them, 20 things taken 19 at a time, 20 things taken 18 at a time, all the way through 20 things taken 1 at a time if you only chose one of these. So it's an enormous combinatorial problem, much bigger than a typical conjoint combinatorial problem. Then you multiply all those by 3, it turns out there was 6.5 quintillion possible combinations that could have been chosen. In this case, there were only about 2,000 out of this 6.5 million, that's quintillion that were chosen, and that at least got the problem down to a reasonable size. So the way we would estimate this, there might be 2 different ways. The first way I would call is the traditional way. So if we go back for a second, is that possible? Yeah. So what I could do would be to estimate an equation for each of these certain rows, if you will, which is a different service, and the equation would say choosing or not choosing it is a function of the price. It's a very simple way, traditional way of doing it. Go forward. What we did, we say what you have to do is you have to have linked equations. The equations have to be somehow linked to one another, because when you're choosing one thing, we want to know what you're going to do with the other thing. Because remember, part of all this was the bundling issue. How were people going to bundle these things? Because in this case, the client didn't know how to go to market. They didn't know what to offer just yet. They knew they wanted to offer bundles. They didn't know what the bundles should be. And rather than making them up, they said, go find out what the bundles are for us. So let's take a look at how well these did. If you're going to choose any one of the items, one at a time, the traditional model actually was right 70% of the time. It got the right answer. If, however, you take into account the fact that these equations are all linked with one another, we were getting it right 84% of the time. Where things really broke down is if we tried to predict combinations. So how many people chose service A and B? How many did A, B, and D? How many people did service E and F? How many did E, F, G, and H? So we had 2,000 times people did stuff. There are obviously some duplications of those services. So excuse me, out of the various, we had 2,000 different combinations. Could we predict, how well did we predict the 2,000 combinations? If you do the traditional model, which we did, we got 9% of the time we got it right. If, however, you use the 20 linked equations, we got it right 42% of the time. Still not great, but 4 or 5 times what a traditional model might get. And we've figured out how to even improve that over time. This was something I did about 5 years ago at this point. So, so menus we think are going to be really important, and I know that at the next Sawtooth conference coming up this fall, they have 2 or 3 papers about doing menu-based conjoint analysis. Second one is understanding this notion of trading up, what I also call discrete volumes, and what I also call multi-unit, multiple discrete choice. Let me briefly, before we move ahead, just tell you what these are. So a trading up, what the notion of trading up is, there's several notions built into it, but the basic one is if you were to go to a place in Paris, you can all buy a cup of coffee, right? And let's say it costs you €2 for a cup of coffee. How many people here go to Starbucks and pay 3 or 4 euros for a cup of coffee? Now, I say to you, is the coffee really that different at Starbucks than you may get at the corner cafe? Probably not. However, there is something perceptually different about Starbucks that gets people to go there and to pay the extra money. They are trading up to get something better. They believe there's something better. How many people here buy green products? Or how many people here buy organic products? There's something perceptually different, or perhaps actually different about those products that is going to get you to trade up and pay more money. And as a marketer, if I have a product that I'm selling like that, I want to get you to spend more money. I want to get more money out of your pocket. But I want to know, what are those things that are going to get you? Is it the brand? Is it a feature? What is it about the delivery of that product that is going to get you to pay more? We want to know that. A discrete volume, I'll show you in a second, and I'm not going to pay attention to the multiple unit, multiple discrete choice problem, but it's a very complicated problem, and the complication comes from something like this. An example I'll give to you is buying little containers of yogurt at the supermarket. When I go to the supermarket, I'll buy 10 of them at a time. I'll buy 2 vanilla and 2 raspberry and 3 strawberry and so on. So I'm making multiple discrete choices. I'm making a vanilla choice, a raspberry choice, a strawberry choice, and then I'm buying 2 and 2 and 3 of those kinds of things. Another place you might do it is with baby food or pet food, where you're buying multiples at one time and you're buying different numbers, and the question is, how do I get you to buy more? How do I price these to get you to buy more? And that's what these multiple unit models are all about. So let's take the case of a premium product that comes in 4 sizes: a medium, a large, an extra large, and an extra extra large size. Typically, we might have a product that looks like that. This could be beer, it could be cereal, it could be any kind of thing whatsoever. But there are also other, let's say an above premium product, and let's say an economy-oriented product, or a private label at a supermarket. And typically, they're in price tiers that look something like this, so that the more you pay, you're going to go up the quality ladder. The less you pay, you're going down the quality ladder. And as you go from left to right, you're typically paying more. But usually, buying, well, let's hit the, I'll go to this idea for a second, which is that people have a budget limit, just how much they're going to spend. And they'll spend, we want to get them to spend up to that budget limit. And so the notion of trading up is, if I have the money to spend on occasion, on certain occasions, or generally, depending upon what the product category is, I'm going to buy the large size of the above premium product, which may cost more than the large size of the regular premium product. Or similarly, if I want to buy, let's say, the extra extra large size, but I don't have enough money, in other words, it's past my budget limit, I might trade down to the private label product in order to buy this kind of thing. So we want to understand the dynamics of those kinds of situations where people are trading up and trading down. So kinds of things that happen here would be, in this case, I'm buying 3 shampoos instead of 1. I'm paying for 1. I'm paying, was that $8 or so? Yes. So I'm paying almost $9 for the single hair color treatment, or I can buy 3 and it's $23. So I'm buying 3, I'm getting a price discount. And the problem was with standard econometric models, because I'm giving this price discount, and especially when the discounts are nonlinear, standard econometric models start to break down and they don't work. Here's another case where you might want to trade up in size. I'll pay more to get a bigger size. This is another kind of trade up that we want to do, to understand. I'll pay more as long as you give me more along the way. You can see that for the 13-ounce bottle, it's, was that $6? $4, excuse me, it's $4. But if I buy twice as much, I don't have to pay twice as much money. So again, the discount for buying more is a nonlinear discount. This, hopefully you can see this. This is something that we did looking at portable music listening devices, like an iPod, okay? And we took the same data and analyzed it with the regular Logit model that is used for doing understanding choice, and then we did the trade-up model with it. We have brands A4, A5, and A6, and if you can guess who this manufacturer is because of the letter A, you're probably right. And we're saying, okay, let's take a look at what the trade-up model would tell us. Well, the trade-up model tells us that for these 2 products, we're doing okay. Excuse me, where is it? Yeah. But A6, it turns out, the trade-up model is predicting that more people will buy it than the standard model will predict. And the reason for that is that the brand, the A6 model for this brand, actually, it turns out, had something that people wanted. And I won't say what it was because it's one of those A products, but it had something that people wanted. So rather than a standard model would say that it would get around, it would get about 10% share. Our model said it would get about 13% share. Now, another thing that we do is to look at how price sensitive people are. So what I'm going to do is I'm going to take the price of A6 and march it across from about $300 on the low end, $299, all the way to $899. You can see the standard model basically says, a nice little price decrease as you increase the price, but it goes from about 10% to about 8%. What the trade-up model says is that it goes from about 16% down to 4%. And without knowing exactly what the product is here, I will challenge you to say which seems more likely to you, that when you go from $300 to $900, you go from 10 to 8, or when you go from $300 to $900, it goes from 16 to 3. So I would argue that the trade-up model is more accurate, and it turns out mathematically it's more accurate than standard models will tell you it is. The other thing is in terms of, we also look at substitution. What happens is I raise the price of A6. Well, in the standard model, people are going to substitute to A5. In the trade-up model, as that, what happens is people start running away to A6. Rather than being a close substitute kind of thing, it's a big substitute along the way. So the trade-up model says it's something different. I want to show you the example of the multiple unit. This is actually done for beer. And so people saw 28 different little buying situations. Each situation offered them 30 different SKUs for purchase from a master set of 52. And then people could choose whichever one of these SKUs they wanted. And it turns out we estimated 52 different effects for each of the SKUs, plus 16 different price effects. Now, what economists tell us is that why on earth would we have 16 different price elasticities? Why don't we have, because price is price is price, people just care about price. They don't really care about price 16 different ways. They care about the price. And similarly, if I have 52 different SKUs, let's say I have the Heineken 4-pack versus the Heineken 12-pack, I'm going to have to generate a Heineken 4-pack effect versus a Heineken 12-pack effect. And let's say the Heineken 4-pack effect is positive and the Heineken 12-pack effect is negative. What does that tell us about people liking Heineken? What we need is sort of a single coefficient for Heineken that tells us whether people like it or not. So what the quantity discount model, which is part of this whole technology, tells us is that we're going to estimate a single brand effect, preference for a bottle or can, willingness to spend. We're going to untangle size and price for one another. And then we're going to also have the ability to add and drop a SKU. Now, I want to warn you right now, here comes the math part of the presentation. This is what the utility equation looks like that we estimate. And it's actually pretty simple, and it's very clever, and it's very elegant, so I'll explain it to you. There's, first of all, a brand effect in this model, right there. And that brand effect is estimated by K times U. So U is the brand effect, and K is actually going to be the coefficient in front of it. Oops. The second effect we're going to have is a quantity effect. How much did you buy? And the third effect is a price effect. I'm going to break these down for you a little more. So what we're calling the worth more coefficient. It's worth more to pay more to get it. So we're going to say which brands are people willing to pay more for. So that whole trade-up idea is going to come in out of this K coefficient. The second thing is there's a quantity effect, but there's going to be diminishing returns. The ln, X is the quantity you bought. We're taking the ln of X, or the log of X. And those of you who know a little bit of math, when you take a log of something, it tends to kind of make it sort of have a diminishing returns look to it. So the log of 12 is not twice as much as the log of 6, a 12-pack versus a 6-pack. It actually turns out the log of 12 is about 1.5 or so times as big as the log of 6. So you have a diminishing returns kind of thing, which brings in the notion of satiation, which is that people can't just keep buying stuff forever and ever. At some point, you're sort of satiating them, and they're becoming to the point where enough, I've had enough. And then finally, for the price effect, we're estimating, as I mentioned to you, what people's budget constraints are, and that's represented by the letter T in the model. And then there's also the price per quantity, and that's the price P of X is the price of the quantity X that you bought. Now, and then finally, there's your willingness to spend up to the budget, which is what alpha is all about. So let me show you these two things right here. If you think about it for a second, let's say I want to buy beer, and I've got $20 in my pocket, but the quantity I want to buy costs $18. What that says is that T is 20, PI is 18, 20 minus 18 is 2, and then I'm asking how much money, I have $2 left over, how sensitive am I to having $2 left over? What is the residual benefit to me of having $2 in my pocket? If, on the other hand, let's say I've got $20 in my pocket, but it costs $30 to buy what I want, that quantity I want to buy, what the bottom part says is that if the price is more than you can afford, you won't buy it. Makes sense. So that's what this equation is all about. Okay, that's all we're putting in here is that. And so what that looks like is you actually look at what the price sensitivity curves looks like. On the top one is a typical price sensitivity curve that you get out of a logit model, which is the choice model. On the bottom is what that equation that you just saw does. And if you think about what's happening, remember I told you about that budget constraint starting to kick in. As you go from left to right, the price of the product is getting higher. And so what's happening is if I have that $18 or 20, let's say I have $20 in my pocket, eventually what's going to happen is I get out to the right and the product will be more expensive than I'm willing to spend, and my likelihood of buying it is going to 0. And the problem with your standard model is that it always, this thing never gets to 0. The red line never gets to 0 in standard models. It says no matter how high you raise the price, somebody's always going to buy it, which is obviously false, obviously wrong. Whereas what the trade-up model says, at some point, you make it too high, nobody's going to buy it. It's going to go to zero. And again, it's that same thing I showed you earlier with how much steeper the curve is under the bottom thing as it is on the top. The other thing that happens is that there's this leveling off that happens on the left side, but I'm not going to go into that. The other thing that happens, we tested up to a 20-pack. The client said to us, what if we put in a 24-pack? Okay? Now remember, we have no coefficient in our model, in the traditional model, because we had 52 coefficients, one for each of the things we tested. We never tested a 24-pack. But given that we're taking the log of X, all we're taking is the log of 24, we can now say, well, let's put a log of product with a log of 24 in the model instead. So on the left is the current shares of a 4-pack, a 15-pack, and a 20-pack. You put in a 24-pack, and you can see that the people like the 24-pack a lot. But unfortunately, what's happening is that the 24-pack and the 20-pack are really fighting one another, and they're really killing the 4 and the 15. They're really going low. The 15-pack is going nowhere. So from the point of view of a marketer, or somebody who is selling these products, we probably want to have something that looks more like the thing on the right, which says, let's going to give everybody a little more room to grow. We'll give life for the 15-pack. We'll have a big pack in terms of 24. We'll get rid of the 20, and we'll have a much better sort of return on what we're doing, comparing the one on the left versus the one on the right. Affordability, and this really gets to the notion of that budget constraint. And so one of the things we can do with these models is we can actually tab out how many people, what's their willingness to pay for each person in the survey. So we can go from, in this case, from, this was pounds actually, from 0 pounds to 44 pounds. And we can look and we can see actually a couple of bumps of affordability. So it would say we really might want to have a product target in the 10-pound range, and we might also want to have a product target in the 20-pound range, and then maybe there's even room for a premium price product in the 30-plus pound range. I'm going to go ahead. Let me show you also how we bring into the consumer into all this. This is an example of some work we had done looking at toothbrushes. And toothbrushes, it turns out, if you get a manual toothbrush, the one you just go like that with, you can spend about $1 or $2 to buy one. Or you can go buy a really fancy toothbrush and spend $100 or $120. And again, I say to you, what is it about the electric toothbrush or a sonic toothbrush that's so much better than going like this yourself, that you're willing to spend 100 times as much to get a different product? And again, it's the notion of a trade-up. How can you get people to buy the really expensive toothbrush? Well, I'm a toothbrush manufacturer. How can I get them to buy the really expensive toothbrush and trade up from a manual toothbrush? Well, when we're done, this is a typical kinds of results we get out of this. So what we can do is we can look at the demographics of the people. So across the row, the columns are income groups, 7.5 thousand, 20,000, 27.5, 35. And on the left are people's ages. And even though we don't have people in every one of these cells, because we're doing modeling, we can actually predict what somebody in each of these cells would be willing to pay, in this case, for a battery-operated toothbrush. So on average, you can see people willing to spend about $10 for a battery-operated toothbrush. But people who are younger and higher income are willing to pay about $21 for a battery-operated toothbrush. So we can now start targeting, if we can, who are those younger, higher income people, and buy our media that way and do our marketing that way to try and get those people to buy battery-operated toothbrushes. In this case, we have an electric toothbrush. And what we were also able to do is the same age by income kind of thing. But in this case, we asked people whether they had gotten a recommendation from their dentist for an electric toothbrush, or they had not, or they had. And what we find is that people who are younger and higher income are willing to spend $49 for an electric toothbrush. However, if they had gotten a recommendation from their doctor, they're willing to spend $187 on an electric toothbrush. So there's really remarkable differences in this willingness to spend. Again, we're not looking at just price sensitivity, we're looking at what's the most somebody's willing to shell out. It doesn't mean they're going to spend $187, but they would be willing to spend up to, but no more than $187. Let's move on. I'm going to move on to the next one. So finally, this is the last part. This is bringing consumers into the industrial design process. And for this is the interactive part of the presentation. I'd like to invite my lovely assistant, Jerome, up to the, up here.
This is like a Tibetan monk.
Yeah.
Kick me or something.
Now, if you think about doing industrial design or design products, really what products are really just their shapes, right? The straight lines, the curves, whatever the case may be. And if you think of this right here, this is a line. And if I kind of take this line, let's say I would go like that, I've made a different kind of shape to it, but essentially it's still the same line, right? All I've done is put a kink in it over here, and I put a kink in it over here. And similarly, if I do that, it's still the same line, but it's a different shape. And so the notion is that there is what is called a shape grammar. Grammar, like grammar constructing a sentence, has a grammar to it. There's rules. And so all I have to do to get from that shape to that shape, I have to tell you what the rules are in order to get from there to there. That was it. Thank you. Okay. Please, the lovely Jerome Sapasco. So let's take a look at that same kind of idea in the notion of testing new products. What designers typically do is they put together a couple of prototypes. We do some market research. We get people to evaluate them. And then when we're done, they really haven't done many prototypes along the way because it's expensive for them to do prototypes. So what we want to do is bring the consumer into the process, test more designs, and understand which design features we can own. In other words, what are the things that are sort of our product design features to give us more equity to our products. So I mentioned, and what we're going to look at is the concepts of a shape grammar, a brand grammar, and then translating those designs into things that are testable. First, here's that line again that I just showed you with Jerome. And you can see that depending upon what grammar I use for that line, I can get a very different car. Everybody get that idea? Okay, so it's still the same line, it's still a line, it's just where I put the kinks and the curves in the line to get a different car. A more complicated example is this one right here. These are all water pitchers, let's say, or coffee pitchers. But as you can see, depending upon what grammar I use, I can get a very different product. But they're all essentially the same design, just where have I put the fat, the skinny, the tall, the arm along the way. Now this notion also extends to the idea of a brand grammar. And I'll show you this product right here with the brand name is sort of blurred out. And I suspect there's nobody in the room who doesn't know what this is, right? We all know that's Coca-Cola. Probably what you didn't know is that the brand grammar of Coca-Cola has been around for almost 100 years. They've been using that shape for a really, really long time. And that brand grammar also extends beyond Coca-Cola to, this is a Buick, which is a car in the United States. Not doing so well, but there are Buicks. That brand grammar also extends to Frank Lloyd Wright, who's a famous architect. When you see a building that's a Frank Lloyd architected building, you know it's a Frank Lloyd Wright building. Andrea Palladio, famous Italian architect. When you look at his buildings, you know it's an Andrea Palladio building. So the idea is that, is there some kind of grammar? Each of these companies or each of these architects is using a particular grammar that identifies it as their product, their creation. Let's take the idea of a Harley-Davidson. Now it turns out a Harley-Davidson, when you really look at it from the side, is just a bunch of triangles and circles, rectangles, right? That's really what it is. So what it can do is go through the process of building a Harley-Davidson. And when I'm done, I could have a brand grammar for a Harley-Davidson. So now the question is, do people recognize this as a Harley-Davidson? And so we can go to Harley-Davidson owners and show them various designs that have different motorcycle grammars, if you will, and have them tell us, do you think it's a Harley or not? Is there a Harley-Davidson brand grammar? Well, it turns out these people this study was done among Harley-Davidson owners. They showed them 10 different designs across the top, 5 across the top, 5 across the bottom. And you can see that the first 2 in the upper left were the ones that were most likely for the Harley owners to recognize as a Harley, and the ones in the bottom were the ones that they were least likely to recognize as a Harley. So essentially what we're saying is there is a Harley grammar along the way, and Harley designers should probably stick within that grammar and not deviate from it very far. Otherwise, Harley people won't think it's a Harley, which is, there's a whole big thing with owning a Harley. You know, it's really a very prestigious brand to own, and you certainly don't want to dilute your brand equity by making a Harley to be a not Harley along the way. How might we do this with a headlight, okay? Now we don't necessarily have a brand grammar. Back to the idea of a shape grammar. Now what's the shape grammar all about? Well, the shape grammar basically says a line. In this case, the line is a circle. And we can put different kinks and curves in that circle and come up with different headlight shapes. So what these folks did was they wrote down the features that there are. They developed an experimental design, like a conjoint kind of thing, and showed people different headlight designs and said, which of these headlight designs do you like the best? And they tested 72 different headlight designs instead of the usual 2 to 4 kind of things that designers test. They tested 72 of them. This guy right here scored 50% higher than any one of the 72 that were tested. So you can see by bringing the consumers in, we can get this notion of a brand grammar and a shape grammar into some place we can actually test it with consumers. Finally, if you're, let's say, I know it's a product very near and dear to the hearts of our French friends, is our bottles for wine. And the question is, what's the grammar of a bottle all about? And so what we might even do something as simple as this, show people different bottles and say to them, which is the bottle that has the sweet and fruity flavor? And you pick one, and then we'll change the shapes again, and which one is the one that's the sweet and fruity? Or we can say the one that's hearty and robust or whatever. And again, so we can make the packaging of the product, the grammar of the packaging, fit with what the positioning of the product is all about. And that's what this stuff is it. So what I think is going to happen, modeling how people make choices is a rich area for doing research. We need some new methods along the way, and I challenge all of you to help me develop those new methods. Constraints are really important. There's budget constraints, there's other kinds of constraints. We've been doing work on constraints in terms of the size that products should be. So for example, selling a case of beer in South America is a tough thing because a lot of people walk to the supermarket and they can't carry the product home. So you have to kind of understand why they didn't choose something. Or they didn't choose it because it's too expensive, or they didn't choose it because it's too big. And finally, we need to pay more attention to consumer and product design. That's all I got.